Okay, good day to you all. We'll be discussing about heat and temperature. Okay, so I have a question for you. Um, I have 4 examples. So the first one is a copper. Letter B is a rubber. Letter C is a piece of wood. Check. Excuse me. And for letter D, stainless steel. So the question for you is, which one is a conductor and an insulator? If you're about to choose two, let's say, what are those two conductors and what are those two insulators? Okay, so some of you will be or have their idea about conductor and insulators. Okay, you can easily choose two of four conductors, which are copper and steel. So these two are conductors. And these two remaining two are insulators. Okay, so a little information about copper and insulator or conductors are the materials that can absorb or allow the electricity and heat to flow. Excuse me. And insulators are the matter that do not allow the heat and electricity to flow. Okay, so let us move. So what are our objectives or goals? First one is to define heat. And temperature. Two is to differentiate at the molecular level. And for number 3, number 3, explain the effects of the heat on the body. let us move. So let us draw first an ice cream, okay, for us to have an introduction. Okay, so ice cream melts on a warm day because heat energy is transferred from the air because it is at a high temperature to the ice cream, and it is a lower temperature. Since the air and the ice cream are in contact with each other, it is what we call conduction. Okay, so this is the air in contact with the ice cream. Okay, this is what we call conduction. So if the sun is shining on the ice cream, let's say this is the sun, it could be what we call radiation. Okay, so let us move. Okay, temperature. So this is a measure of the average kinetic energy of the particles in an object. So it does not depend on the mass of the object. So this is also not a form of energy. So, but it can be measured directly with the use of thermometers. Okay, so it can be expressed in degrees Celsius, Fahrenheit, and Kelvin. Okay, so let us move. What about the heat? So this is the thermal energy transferred from a hotter to a colder materials. So it means this is a form of energy. Cannot be measured directly, but can be measured from the temperature and mass of the material. So it can also be expressed in calories and joule. All right. Let me draw a boiling water here. Temperature and heat, okay, are related, but of different concepts. So as you can see, this is a boiling water. Okay, for example, heat is the energy, while temperature is the measurement of that energy. Okay, let's move. Okay, so when there is a difference in temperature, energy flows. Okay, so the transfer of energy from a substance of higher temperature to a substance with a lower temperature is called heat transfer. Okay, just remember, if there is always a difference, okay, of temperature, okay, energy flows, because the heat of a higher temperature will be flowing to a substance with a lower temperature, so it transfers. So of course, heat transfer occur. Let's move. Okay, let us use again the concept or example earlier, which is the boiling water. Okay, so this is what we call boiling water. So these are the water in gas state. That escapes from liquid. Okay, so these, okay, so the bubbles contain water in a gas state. So vapor pressure is equal or greater than atmospheric pressure. Okay, so let us move. Okay, so the temperature is how hot or how cold an object is. Okay, so the heat is transferred to the object. Okay, so the energy, this is energy being transferred. Okay, so the heat is transferred to the object. Okay, so the heat is a form of energy. Okay, as so let us go back to that. Okay, so the temperature can be measured in Celsius, Fahrenheit, and Kelvin. This is not a form of energy. Okay, can be expressed into these three. How about the heat? Okay, thermal, this is an energy. Okay, energy that can be transferred from a hotter to a colder materials. Okay, this can be expressed in calories or joule. So what could be the effect of heat to a substance? So when heat is added to a substance, the molecules and atoms vibrate faster. Okay, so as atoms vibrate faster, the space between atoms increases. The motion and spacing of the particles determines the state of matter of the substance. Okay, the end result of increased molecular motion is that the object expands and takes up more space. Okay, so this is thermometer. So what we have said earlier, when heat is added into a substance, of course, okay, the molecules and atoms vibrate faster. Okay, so when heat is added on the substance, as you can see, the molecules vibrate faster and its atom. Okay, so as atom vibrate faster, the space between atoms increases. Okay, so it will become more will have more space in between. Okay, so the motion and spacing of the particles, of course, determines the state of matter of the substance. Okay, so the end result of increased molecular motion is that the object expands and takes up more space. So that's the end of our discussion about the heat and temperature and the effects of heat to a substance. I hope you enjoy listening. Thank you and goodbye.